In today's lesson, we went over the problem on page 142. It's a page-long problem, and it's about two bicycles. So in the problem, we are given some information. The problem says the wheels on Kai's bike, this one here is Kai's bike, are 27 inches in diameter. So what do you know about the diameter of a circle? On a bike, the spoke is the radius. So these skinny things that hold the wheel in place, those are a radius, and those are called spokes. The diameter, think about the formula, it's 2 radius, is just from one end point of the wheel to the other end point of the wheel, and it passes through the center. So that is the diameter of Kai's bike. The problem says that it is 27 inches in diameter. The problem then says his little sister Masako has a bike with wheels that are 20 inches in diameter. Okay. So this is Masako's bike. And the problem says that her wheels are 20 inches in diameter. Oops. Again, this is a radius, and then this is a diameter. And the diameter is 20 inches. Okay. Kai and Masako go out for evening rides around the neighborhood. Okay, let's just review really quickly what the parts of a circle are. So if we have a circle here, this is the radius, this is the diameter, and then the length around the circle, also known as the perimeter of the circle, is called the circumference. Now think about a wheel when it rolls. When a wheel rolls, it starts at one point on the circle, then this point hits the ground, then this point hits the ground, this point hits the ground, so on and so forth until the whole end of the wheel from where you started makes its way around to the ground. So this length of the line created by a circle rolling is equal to the circumference. So if we are able to find the circumference of a circle, we know that in one rotation, the length it creates on the ground is equal. So let's look at the problem. The wheels on Kai's bike, we just did this part. Okay, great. I'm just going to redraw my little circles right up here because remember, pictures are very important. You can't answer the question if you don't have a picture. So this is Kai, and this is Masako. Okay, let me draw hers just a little bigger. Okay, those are little mini pictures. Okay. How far will Kai go in one complete turn of his wheels? Now remember, we just reviewed that the circumference is equal to one complete turn of the wheels is how far the wheel will go. So Kai, his wheel is 27 inches in diameter. We're going to use the circumference formula in order to solve for one complete turn of his wheels, how far he will go. So we need to find the radius first before we can use the circumference formula. So we are given the diameter. Diameter equals 2r. The diameter is 27 inches. Solve for r, and we get the radius is equal to 13.5 inches. So now we can use that radius in the circumference equation. And we get circumference equals 2 pi times 13.5 inches. So the distance that Kai's tire will go after one complete turn of his wheel is 84.8 inches. Here, let me make this a different color so we can use it again. 84.8 inches. Okay, and the next question, how far will Masako go in one complete turn of her wheels? Same thing. We are given the diameter. Diameter equals 2r. The diameter in the case of Masako's wheel is 20 inches. Let's solve for R. The radius of Masako's wheel is 10 inches. We can plug that into the circumference equation, which is 2 pi r. And we get circumference equals 2 pi times 10, which equals 62.8 inches. I'm going to put this down here in a different color. 62.8 inches. And that is how far Masako's wheel will go in one complete turn. How far will Kai go in 500 turns of his wheel? Okay, well, we know that in one turn, Kai will go 84.8 inches. So in 500 turns, he will go X inches because we don't know. So let's cross multiply, and we get X equals 84.8 times 500, which equals 42,400 inches. How far will Masako go in 500 turns of her wheels? All right, well, in one turn, Masako will go 62.8 inches. I found that up here, remember? Okay. So in 500 turns, we're setting it up the same way we set up the other one. She's going to go X. We don't know. X inches. So 500 times 62.8 gives us 31,400, because I'm cross multiplying, equals X. Okay, so that's our answer, 31,400 inches. Now it asks us, how many times will Kai's wheels have to turn to cover 100 feet? 12 inches are equal to 1 foot. Read the question. This is obviously important information, this conversion right here. So, let's take a look at the question again, given this important information. How many times will Kai's wheels have to turn to cover 100 feet? Well, we know how many turns one complete turn of his wheel is in inches. We know it's 84.8 inches in one turn. But we need to find out how many turns his wheel will have to make in order to cover 100 feet. So we need to convert 100 feet into inches, so that way it's an even comparison. So the problem tells us that there's 12 inches in 1 foot. We know that Kai's wheel in one complete turn goes 84.8 inches. So we need to turn that into feet, which we don't know, so that is X. We will cross multiply, and we get 84.8 equals 12x. Divide both sides by 12. X equals 7.06666667. Okay? Okay, so I made a bit of a mistake in this one. Let's just reset up the ratio, okay? So we know that there are 12 inches in a foot. I skipped a step before. We have to make sure that we find out how many inches are in 100 feet before we find out how many how many turns we'll have to cover 100 feet, okay? So, that's okay. That's why it's important to make sure you can diagnose your own mistakes, because if this was a test, I wouldn't be there to help you. So we have X inches are in 100 feet. So we will cross multiply now. And we get 1,200 equals the number of inches in 100. Hold on, this is very messy. Inches in 100 feet. Okay, so then we set up another ratio, and we have in one turn, (84.8 inches. So in how many turns will we have 1,200 inches? We cross multiply again, and we get 1,200 equals 84.8x. Divide both sides by 84.8, and you get x equals 14.1. All right, so now it asks us, how many times will Masako's wheels have to turn to cover 100 feet? So it's asking us the exact same question again, but this time with Masako's wheel. So we already know how many inches are in 100 feet. We found that up here, so I'm just going to use that number again, okay? So we have 1,200 inches in 100 feet. Okay. So let's set up a ratio. We have in one turn, Masako's wheel covers 62.8 inches of length. So how many turns does it take to cover 1,200 inches? We'll cross multiply, and we get 62.8 equals x equals 1,200 divided by 62.8 divided by 62.8, and we get x equals 19.1. I'm just going to draw a little line here so you can see where this problem ends and the other problem begins, okay? If you want to check your work. And now, for the final two parts, the question says, how many times will Kai's wheels have to turn to cover 1 mile? Okay, so this time we're covering a mile, and it's Kai's wheels. All right, so we know that from the other page we're going to be using 84.8 inches as the total distance covered in one revolution of his wheel. So we want to know, in one turn, Kai covers 84.8 inches. So how many turns will it take for him to cover? Oh wait, we don't know how many inches are in a mile. So we need to do that conversion in order to figure that out. So they tell us that 5,280 feet are equal to 1 mile. So if we know that 12 inches are in 1 foot, how many inches or x inches are in 5,280 feet? We'll cross multiply, and we get x equals 63,360 inches. This many inches are in 1 mile. So we're going to plug that number of inches into our ratio over here that we have set up, and we cross multiply. And we get 84.8x equals 63,360 divided by 84.8 divided by 84.8, x equals.
Maybe I added 1/4.
And we get 747.
So, do you think this base into?
Now we're doing the same thing that we did up here, but with Masako's wheels. So, looking back on our work, Misako's wheel goes 62.8 inches in one turn. Okay, so 62.8 inches in one turn. Okay. So in 1 mile, we found up here that there is 63,360 inches in 1 mile. So we're going to need that info as well. So we're kind of just gathering our information to answer the question. Now let's see. In one turn, Misako's wheels cover 62.8 inches. We are trying to find, because the question asks us how many times will the wheels have to turn? How many times will the wheels have to turn? So we don't know the turns. X is the turn. Will happen in order to cover 63,360 inches. So we cross multiply and we get 63,360 equals 62.8x. Divide both sides by 62.8 to isolate the variable, and we get x equals, and we'll get 1,008.9 turns. You can't have 0.9 of a turn, right? That doesn't really make any sense. So we're going to use our critical thinking to determine the wheel will need to turn 1,009 times in order to cover 1 mile. And that is the answer to our question.